Chapter 4. Condensing Appliances. Condensing appliances require special venting systems that differ from those used with non-condensing appliances. To understand the venting process, it's important to know that condensing appliances achieve their higher efficiencies by extracting almost all of the heat from the combustion gases before they pass through the venting system and are emitted to the atmosphere. Condensing appliances don't offer more efficient combustion than non-condensing appliances. They simply extract more heat from the combustion gases than non-condensing appliances. In a non-condensing appliance, water vapor, one of the byproducts of combustion, travels through the appliance and escapes through the venting system to the outside atmosphere where it cools and condenses. In a condensing appliance, the flue gases pass through the heat exchanger for a longer period of time, allowing the appliance to absorb more heat. These gases condensate in the appliance as they cool. Water vapor drips out of the heat exchanger into a trap instead of passing to the outside through the venting system. The condensate is acidic, with a pH of about 3.5, and the trap must be piped to an appropriate drain location. Continual exposure to condensate may injure plants and can damage certain building materials, including metal, wood, stone, and concrete. Some local codes require that an acid neutralizing kit be connected to protect the pipes and sewer systems. Some condensing appliances are equipped with a blocked drain switch to prevent the unit from operating in the event of a blocked or slow-moving drain. The switch is wired in series with the primary control's T and T circuit and opens if the condensate level gets too high. A condensate pump may be needed to remove the condensate to a safe place when a suitable drain is not present at the appliance, or the drain is above the trap outlet of the appliance, or the drain line cannot be sloped downwards for its full length to the drain. The venting material of condensing appliances differs from those of non-condensing appliances because their flue gas temperatures are so low. PVC piping is normally used as the venting material for condensing furnaces. However, since PVC starts to soften and lose its shape at about 150 degrees Fahrenheit, and condensing boilers can have flue gas temperatures between 190 and 350 degrees Fahrenheit, polypropylene or stainless steel must be used for venting hydronic appliances. There are a number of requirements that must be met when venting with PVC, and the specific manufacturer's recommendations must always be followed. In general, manufacturers agree that the vent size reduction is not permissible. Horizontal runs must be supported every 3 to 5 feet to prevent sagging, joint separation, or pipe blockage. The vent system must slope upward from the appliance to allow proper drainage of condensate. And vent pipes passing through the unheated areas must be insulated. And there are significant differences in a number of areas, including in the pipe. Some manufacturers specify rigid 40 PVC only, while others also accept ABS. In the fittings, some specify DWV, and some accept Schedule 40, and that the minimum and maximum length of piping. So it's critically important that installers and service technicians always follow the specific manufacturer's instructions for the appliance they're working on. The same situation exists with the venting of condensing boilers as with condensing furnaces. There are a number of requirements that must be met, and specific manufacturer's instructions must always be followed. There is no standard set of instructions. Different models of the same boiler have different requirements, including allowable vent lengths. The terminal location requirements for condensing appliances are similar to those of power vent systems. Because the appliance is likely to produce a visible plume due to condensation, surfaces close to it will be coated with water vapor. The exhaust vent should be located in an area where the condensation will not cause an unsafe condition, for example, under a deck where icing could result. This illustration shows recommendations by some manufacturers regarding the terminal locations of condensing appliances. The vent hood must be at least 1 foot below windows. However, a minimum 4-foot clearance is recommended. At least 1 foot above the grade. At least 3 feet from inside corners, although 10 feet is recommended. At least 1 foot below the soffit of a roof. At least 7 feet above public walkways. And at least 1 foot to the side of doors and windows. In addition, both the vent hood and the air intake must be at least 5 feet from any supply tank vents. This ends the section of this program based on NORA's Advanced Venting book. However, venting technology that enables Oilheat to achieve a 93 AFUE rating without condensing is now available. Roger Marin of Energy Kinetics explains this process, referred to as dilution venting.
Hi, I'm Roger Marin, presenting on dilution air venting as an enabling technology for oil heat advances. Dilution air venting is a proven technology which has been used with gas water heaters for decades and with oil heat boilers since 2011. As can be seen in the venting animation, dilution air reduces venting temperature to enable higher efficiency, cost-effective, and desirable venting options for oil heat where an existing chimney is not adequate. Let's review some venting options and challenges. When higher efficiency boilers have gross stack temperatures below 325 degrees, natural draft becomes marginal or ineffective with conventional clay-lined and even stainless steel-lined chimneys. Lower stack temperatures may condense and may cause damage to clay liners. Condensate mixed with sulfur and flue products can also aggravate long-term serviceability and performance. PVC is possibly an option as it is corrosion resistant and inexpensive, although it has a maximum operating temperature of 140 to 149 degrees. It's also no longer code compliant for condensing boilers in several jurisdictions. Boilers typically operate at 160 to 180 degrees, making hot water. Another option is single-wall stainless steel venting, which is compatible with temperatures and conditions suitable for non-condensing and condensing boilers, although stainless steel is not as easy to work with and it's more expensive than PVC. Oilheat has a unique venting and efficiency advantage as it can reach up to 93 AFUE without condensing. This is good news because high efficiency can be achieved without corrosive condensate. Ultra-low sulfur fuel is now standard, delivering extremely clean operation with virtually no particulate emissions. Real annual efficiency achieved 87.5% AFUE with a low-mass thermal purge oil heat boiler has been demonstrated to outperform boilers rated at 95 AFUE. Building on this technology and increasing the AFUE ratings into the 90s further expands on the efficiency advantage over competing fuels. Superior venting materials are available, allowing faster, easier, and more cost-effective installations too. How can oil heat boilers operate at 90 plus AFUE without condensing in the boiler or the flue? Oil has lower hydrogen content than other fuels, so less water is produced as a product of combustion. Oil heat actually condenses around 93 AFUE in boilers. At 90 to 93 AFUE, it may still condense in the vent if the flue temperature drops. To avoid corrosive condensate, simple, proven technology can be used to dry out the flue gas and provide reliable venting, even in Arctic climates. How? With dilution venting. Dilution venting takes a page out of the long-established gas water heater playbook. Dilution venting enabled PVC venting on water heaters, greatly improving ease and cost of vent installation versus metal natural draft venting. Here's how it works. Hot flue gases enter the bottom of the fan assembly. Dilution air from the room or outside air enters and mixes with the flue gas in the fan. The mixed flue gas exits cool enough to vent in PVC. It's cooler than the original flue gas, but warmer than the dilution air, so it's actually drier and less prone to condensing. In sub-freezing temperatures, outside air is extremely dry. An additional benefit is that the fan assists in venting where natural draft will not be effective. Here's how it works in a boiler. Energy Kinetics 90 Plus Resolute has a low stack temperature due to a very long flue pass. Flue gas is mixed with outside air in the dilution air fan, resulting in cooler and drier vent products. This vent is positive pressure, so appropriate vent materials must be used. It cannot be vented in a conventionally clay-lined or flexible stainless steel lined chimney. Polypropylene is the vent material of choice for safety, affordability, reliability, and ease of installation. Polypropylene is widely available in various sizes. It's competitively priced and is rated up to 248 degrees Fahrenheit with oil heat. It has the security of high temperature solid joints retained by a locking ring for safety as well. The Ascent Plus Combi fires up to 1 gallon per hour and is ideal for tankless coil replacements. The 90 Plus Resolute, introduced in 2011, and the Resolute RT also fire up to 1 gallon per hour and are suitable for homes that consume up to 2,000 gallons of oil per year. The Resolute models use a hot water tank and a thermal purge control for the best available real annual efficiency and highest hot water output. All models can vent up to a maximum length of 50 feet equivalent intake plus 50 feet equivalent exhaust in polypropylene. Dilution air vent models have an extra wrap around the spiral pressure vessel, extending the flue path by 40%. This reduces the stack temperature to a point that seamlessly integrates with the dilution air fan to deliver vent temperatures that are very compatible with polypropylene venting. Comparing polypropylene and PVC installation, polypropylene has many advantages other than a somewhat higher first cost. Installation of polypropylene is easy with lightweight piping and fittings. Install just a couple of hangers, hold the pipe in one hand and install. PVC comes in 10-foot sections and often needs 2 people to install. Polypropylene has the security of high temperature solid joints retained by locking rings with 100 pounds holding force. PVC is cement only and each joint is subject to installation skill. Sawzall blades cut through polypropylene more quickly and easily than PVC, although both are easier to cut than stainless steel. Polypropylene has removable joints for convenient future inspection and service. PVC must be cut and replaced or spliced with couplings if any inspection or service is required. Polypropylene also has attractive vent termination options from sidewall, roof, or using existing chimney as a chase. The temperature requirements for oil heat and hot water boilers means PVC cannot be used as a vent material. Either PVC or polypropylene can be used as intake materials. Here's a top view of the Ascent Plus Combi and Resolute RT venting. Just as with the 90 Plus Resolute seen earlier, outside air flows to the dilution air fan and to the burner for combustion. Dilution and cooler vent gas is exhausted through polypropylene venting. Here's a Resolute RT with polypropylene intake and vent piping shown. The cover is removed to expose the vent fan and other connections for the photo. A flexible polypropylene liner may also be used as a vent using an existing chimney as a chase. Here, a rain trap thimble is added to prevent any rainwater from flowing back to the boiler. As the flue products are warm and relatively dry, the trap dries out and does not normally need any drain. You will also notice that there is no draft regulator. Energy Kinetic's Oilheat polypropylene vented boilers are UL listed for installation without a draft regulator. Intake air may be supplied through the same chimney chase as the flex vent, although it needs a separate flexible polypropylene liner. Intake or combustion air may be provided through a sidewall as an alternative. Look for more oil heat products with dilution air as they become available. These 3 polypropylene vented boilers cover the majority of residential oil heat boiler applications and have a proven track record with industry standard components including the burner, circulator, hydrostat, and more, combined with a proven 30-year pressure vessel. I'm Roger Marin. Thank you for watching.